can you tell me what's your favorite tool on the site?
Based on the information I found, one standout tool is the EEG music generator. It transforms brainwaves into music directly in the browser, showing the platform's interactive and creative side. There's also a cochlear implant simulator that gives a unique glimpse into hearing science.
So I loaded the EEG-to-music page. Can you actually describe what it is about?
EEG-to-music page is an interactive tool that converts brainwave data into sound, letting users hear brain rhythms as musical notes.
Can you read the description on the page?
The description on the page explains that the tool transforms EEG data into both visual and auditory experiences. It lets users explore brainwaves through interactive graphs and music generated from EEG readings. You can select channels, adjust time windows, apply filters, and hear how different sections of the EEG data sound.
Okay, and where's this particular EEG brainwave recordings are coming from?
The EEG brainwave recordings for this tool come from intracranial EEG data provided by NeuroVista, available on the platform ieeg.org. This gives users real-world neural activity to explore through both visual and auditory outputs.
Yeah, describe the future directions, but also can you find if there is a play button on the page? So or do I have to scroll through the EEG turning into music manually? Can you look it up?
The EEG-to-music page does let you scroll through EEG data manually, but there is indeed an auto volume and auto duration feature that automatically adjusts the sound. There's also mention of future directions, like exploring real-time EEG-to-music conversion and improving features like volume indicators and more refined control. As for a direct play button, the tool focuses on letting you listen by interacting with the scroll and settings.
Okay, so is that correct? There's no play button at the moment. We'll probably have to add it into future directions. But also, can you explain the different types of controllers on the page? Essentially, we want to see how we improve the controllers. There are probably too many, and how we improve the user interface, adding a play button, things like that. Can you explain?
Sure. On the page, the main controls include a large scroll bar to navigate through EEG data, channel selectors to choose specific brainwave streams, and time window adjustments to zoom in or out. There are filter options to isolate specific frequencies, and auto volume and duration toggles to adjust the sound output automatically. Adding a play button could simplify how users interact with the audio, making it more intuitive.
Okay, so can you generate a list of things that we need to change?
Absolutely. Here's a quick list. First, add a dedicated play button for easier audio playback. Second, simplify the control panel by grouping related options like filters and volume under collapsible menus. Third, enhance the scroll bar precision for smoother navigation through the EEG data. These changes should make the interface more user-friendly and intuitive.
Okay, now there is another thing about this particular web application, the way it's being designed, the architecture of it. Currently, it's a Flask. It's a Flask web application, so we're actually trying to move it to front-end only. The data can be turned into a JSON file or whatever.
Moving the data processing to the front end and converting EEG data into a JSON format can reduce lag and improve performance. This will make the web application more responsive and allow smoother interaction with the controls and audio feedback.
Okay, but generally, can you describe how do we transfer like a Flask application like this into front-end JavaScript only?
Sure. Generally, you migrate server-side logic like data processing into JavaScript using libraries like Web Audio API or D3 for visualization. You'd replace Flask endpoints with static JSON files or real-time data streams and handle user interactions directly in the browser, leading to a more dynamic, responsive experience.
Yeah, so we have this BioniChaos.com/EEG-music. It's currently a Flask application. We're trying to turn it into a HTML front-end only web app to do that. Yeah, the EEG is already JavaScript. No, wait. So currently there's a backend to it, which we are trying to avoid. The data is published as text, so it is on the page, on the website already. So it should be accessible. It is a text file, but it shouldn't matter. I mean, we can turn it into JSON if absolutely necessary. Okay, so we're currently having the data, the EEG recording, the brain waves in a text file. It's in a static/data folder on the website. Now, yeah, but currently the EEG-to-music web application is still a Flask application. So how do we go about turning it into standalone JavaScript, ideally single HTML?
To convert it into a standalone JavaScript app, you'd first move all data handling to the browser by loading the EEG text files as JSON using JavaScript. Then replace Flask routes with front-end logic for rendering and controls. You'd handle user interaction, graphing, and sound generation all in the browser using libraries like D3, Tone.js, or Web Audio API, creating a fully client-side, single-page application.
Okay, that sounds good. So using D3, Tone.js, Audio API, that sounds good. But so currently we have the folder for this web application. We have static EEG JavaScript. We have the index.html. We have the app py that's actually accessing the data, processing the data. We have some information. Yeah, so how do we... So can we load it into... So if you sent it to a developer, a JavaScript developer, can you just send them all these files to convert it into front end?
Yes, you can package all the static files, the HTML, JavaScript, and the EEG text data into a bundle. The developer can then load the data using JavaScript, parse it, and use libraries like Tone.js for audio fully in the browser. That way, no backend like Flask is needed.
Okay, so can you give a summary of the whole thing?
First, you've got a Flask app serving EEG data and generating music. The goal is to convert it fully to a front-end JavaScript application, loading EEG data in the browser and using tools like Tone.js. This would make it a standalone interactive web tool without needing a server backend.
Yeah, so we have this EEG-to-music conversion. Yeah, that's how it sounds like, by the way. There's currently no play button. We can improve it by miles. But first we need to convert it from a Flask application, which we originally made it into a front-end only. We'll try Gemini, Code Assist, Agent Mode, whatever model it's using. Don't really care as long as it's working. Hey, can you give a summary of what we are trying to do?
You're aiming to transform a Flask-based EEG-to-music web application into a purely front-end JavaScript tool.
That's right.
This means loading the EEG data directly in the browser, processing it with JavaScript, and using libraries like Tone.js to generate sound, all without relying on a backend server.
Okay, and can you generate... So the original data is in a text file. It's currently in a static data folder on the website on a server. So we'll share it with Gemini. Then we have this Python script loading the data. We have an EEG JavaScript doing some EEG processing, basic stuff. That's the one that's turning EEG into music, I think, as well. We have the HTML, and we have an info text file. So I think we need to share all this with Gemini. So can you generate the prompt for it? And we'll generate them step by step, one file at a time, starting from the Python code and then the EEG.js. So essentially, yeah, we want to convert all this into a single HTML with all the JavaScript in line.
Sure. Here's a clear summary you can share. We have a Flask-based web app with the following components: a Python backend that loads EEG data from a text file, a JavaScript file that processes the EEG data and turns it into music, an HTML page, and the original EEG text data. The goal is to convert all this into a standalone front-end JavaScript app by embedding the logic directly inside a single HTML file. You can give this overview to the developer, then share each file's code one at a time, starting with the Python code, then the EEG JavaScript, and finally the HTML. That way they can refactor everything step by step into a pure front-end solution.
Okay, so we select the Python code.
Understood. Start by selecting the Python code that handles loading and processing the EEG data. Once we have that, we can outline the next steps to convert it into JavaScript.
Okay, so Gemini Code Assist should be able to see the Python first, but then it should ask for the rest of the files.
You'll feed Gemini the Python code first, and then share the EEG JavaScript and HTML step by step. That way it can convert everything into one standalone front-end HTML with inline JavaScript.
Can you give a quick summary and tell us what problems we might face during this conversion?
The main steps are, first, converting the Python data loading logic into JavaScript that reads the text file on the client side. Second, ensuring that the EEG signal processing logic from the existing JavaScript is self-contained. And third, combining it all into a single HTML file with inline scripts. Potential problems include handling file reading in the browser, adapting Python numerical operations to JavaScript, and managing performance for large EEG files in pure client-side code.
Okay, we're having a Gemini looking at the code. It's still processing the Python. Hopefully it will ask for the rest of the files as well, because I don't think it can see them at the moment.
That makes sense. The key is sharing each file step by step so Gemini can integrate them. You'll likely face challenges with adapting Python's data parsing and any server-side logic into a fully client-side JavaScript solution. But once all the pieces are there, a unified single-page JavaScript application can handle it all.
The other thing we forgot is that we probably for now want to keep the current thing as is. So it's saying we have the Python code. This Flask application reads EEG data, performs signal processing like filtering and wavelet denoising, and serves the result. To proceed with the converting this into a standalone front-end application, I'll need the corresponding JavaScript and HTML file. Please provide the EEG file next. So provide the EEG file, but yeah, we also need to start a new a new project under a new name. So this one's called EEG_music. That one should be called like same thing, but front end only something.
You'll create a new project called something like EEG Music Frontend and migrate all the processing to JavaScript. You'll need to convert the Python signal filtering logic into JavaScript, handle file loading on the client side, and ensure smooth playback using the Web Audio API. This will give you a fully standalone front-end solution.
Can you give a quick summary of what we're doing so far, and how does the web application looks like at the moment? And also, can we actually dive into the details of what, or currently what do we have as controllers on the current web application?
So far, you're building a new web application that merges all the technical information and instructions from the previous Flask app onto a single HTML page. The current web app includes an HTML page with a canvas, some JavaScript for interactivity, and a Python backend. As for controls, you likely have user input elements or buttons that interact with the canvas or trigger certain backend processing. You can always refine or add more controls as needed.
Okay, that's it. So it says, so it received the content from the index, the info text. Here's my understanding of the project primary goal. The Flask application will be converted into a simple standalone EEG-to-music front-end index.html file. All processing logic from the Python backend will be migrated to client side. file structure. The new directory EEG-to-music frontend will be created containing that final index.html, which it has, and the data subdirectory for the EEG text file, backend logic, blah blah blah. The entire replace JavaScript, determining filtering. Okay, wait a sec. Replace the new JavaScript functions that perform the required signal processing, detrending, filtering, wavelet, denoising, PSD calculation. It's the power spectrum density analysis, whatever. Yeah, we'll have to make sure it's actually correct. Therefore, the the Python file will not be updated, as it is will become obsolete for this new version. Front end refactoring, yep, CSS, JavaScript. Okay, just with the CSS, maybe we can just start fresh. We didn't have CSS for this one. I think we have a global CSS for the whole website. So I'll share that with you as well, unless you have access. I can just provide the link to it. It's a local file, style CSS for the whole website. So we don't mind. We would not be modifying it, but we do need that as a reference, and then we'll have some specific styling for this web application. So can you summarize all that and generate the prompt talking directly to Gemini, who is currently the web developer for this?
Gemini, we're converting the old Flask app into a standalone HTML frontend. All Python backend logic, like signal processing, detrending, filtering, wavelet denoising, and PSD calculation, will be ported to JavaScript. We'll place the technical details at the bottom of the page below the canvas. Use the global style sheet as a reference, but add specific styling as needed. The Python file will be obsolete, so all logic should now reside client-side. Let's ensure everything fits the new design.
And can you give an overview of what the website is all about again? BioniChaos.com. Eventually everything we do is available on the site. So can you repeat that and expand?
The website, barnacules.com, is the central hub for everything related to the band.
No. What are you talking about? It's BioniChaos.com. It's BioniChaos.com. Maybe you can look it up. I thought we did already before, but yeah, look it up. And this web application is already deployed, but we're updating it to frontend-only and replacing the old Flask application.
BioniChaos.com is an interactive web-based platform for biomedical data science and education. It offers tools like brainwave to music generators, ECG simulators, and interactive visualizations for learning complex concepts, all running directly in a browser. Its focus is on making sophisticated biomedical science more accessible and intuitive, especially for students and educational use.
You know what the agent is doing? Still doing something.
It seems the agent might
I have created a standalone index.html. Yep, the correct one. This single file now contains the necessary HTML, CSS, JavaScript, completely replacing the previous Flask-based backend. The Python signal processing logic for filtering, denoising, and spectral analysis have been migrated to JavaScript using a combination of standard algorithms and external libraries. The UI has also been updated to more responsive and user-friendly. The application is now self-contained. Okay, so we can go ahead and test it, I would imagine. Okay, we're having errors. Errors. It's a Plotly latest min.js and Plotly latest JS are no longer the latest release of Plotly JS. Okay, is this some sort of version control? Models not defined. There's some sort of reference error. Loaded and parsed 4,000 data points. Okay, so it's actually loaded the data. So that's good. Why is it an error then? Ah, no, it's not an error. And failed to load or parse EEG data type error. Yeah, everything we do is available on BioniChaos.com. Go check out the website, provide your feedback. Maybe the bot Perplexity can repeat it for you in a better way, more comprehensive, more encouraging.
Everything we do is available on bionichaos.com. Go check out the website and share your feedback. Your insights will help make it even better.
Yeah, can you expand on it and just give a general overview for the whole website as well, and how this tool is relevant to the whole website topic?
BioniChaos.com is a platform packed with interactive tools for biomedical research and education, focusing on real-time signal processing, visualization, and simulation. It offers tools like an EEG simulator, an advanced audio analyzer, and a gesture-based music generator. Overall, the site integrates AI, web development, and biology, making complex biomedical data accessible and interactive for students, researchers, and curious minds.
And can you look on the front page? There's this real-time signal amplification microscope that uses the webcam to identify your blood flow pulse.
Exactly.
Can you summarize? Can you look it up? Summarize that one and tell what the URL is for?
The real-time signal amplification microscope on BioniChaos.com uses Eulerian video magnification to reveal subtle changes in skin tone caused by blood flow, extracting pulse signals from webcam video. It processes the video in real time, applying filters to remove noise and accurately calculate your heart rate. The direct URL for this tool is https://bionichaos.com/facebloodwebcam.
Okay, and can you describe this tool real quick? This is probably the most successful one we did so far on as part of the BioniChaos project.
The real-time signal amplification microscope on the BioniChaos project analyzes subtle skin tone changes from a webcam feed to detect blood flow and calculate your pulse in real time. It uses advanced filtering and amplification techniques, letting users visualize their heartbeat right from their browser without extra equipment.
Right, and how would you validate if it's actually working or not?
You can validate it by comparing the measured pulse against a known accurate device, like a smartwatch or a medical-grade pulse oximeter. You'd run both at the same time and check if the heart rate readings match closely across different conditions.
Can I sometimes get a good signal, and sometimes it's a bit noisy?
To improve accuracy, try to keep your face steady, ensure consistent lighting, and compare with a reliable heart rate device for calibration. This helps confirm that the readings are on track.
So a regular smartwatch, what's the error margin for beats per minute? Would it have? Is it like ±1 or ±2, whatever? Should I compare it to like a chest strap or something more accurate? What do you think?
Typically, modern smartwatches have a margin of error of around ±3% in heart rate readings under normal conditions, which is roughly a few beats per minute. However, they can show greater inaccuracies during intense exercise or irregular rhythms. Chest strap monitors are generally more accurate, often within ±1 beat per minute, making them a solid comparison for validation.
Okay, let's check Gemini real quick. So it's replaced the Plotly version. Well, we have to accept it because we're not doing any coding ourselves.
That makes sense. The best approach is to validate with a highly accurate reference, like a chest strap, and compare the readings over time. That'll give you a clear picture of how reliable it is.
No, we're back to the... What were we doing before? Do you remember what we were doing before? Because I forgot.
We were talking about the real-time signal amplification microscope from the BioniChaos.
No. We were doing EEG-to-music conversion.
Ah, I see. We were actually discussing the real-time signal amplification microscope tool as part of the BioniChaos project and comparing its accuracy to smartwatches. There wasn't an EEG-to-music conversion in that discussion. Are you thinking of a different project or something else you had in mind?
No, okay, we're getting different errors for it. Now we're having trouble loading the data file. We'll give it to Gemini. But yeah, it's a text file. It says model some module is not defined, reference error. So we had this before, but also it failed to load or parse the EEG data, type error. The trend is not a function. Probably had to give Gemini a sample of what the file looks like, so maybe we can prompt Gemini directly, because it feels like it's gonna have trouble. You're right, the previous fixes were insufficient. The new error shows that FFT.js has the same module compatibility problem, and there is a name collision with the dtrend function. Yeah, a lot kind of comes down to access to updated information. Okay, can we try to review this code and try to fix the code? I'm getting the following errors at the moment, so maybe we can explain what's going on. Prompting. And yeah, let's do granting with Google search, so it actually finds the correct libraries and things. Maybe. Okay, so I have a response from Gemini. Let's see if it's actually working. FFT library. Yep. Dtrend, perform dtrend. FFT library, I'll remove the external FFT. Embedding a proven browser native FFT implementation directly into the page script. Okay, so that's actually what we do like. So we have like a wavelet transform JS and a Plotly JS, but it removed the third one. Okay, so replaced FFT, fixed the naming conflict. It's fine that it's able to fix things. Why make mistakes to begin with then? Not sure. It's finished working. Okay, let's clear the console. Okay, so it's actually working. It's actually working. What do you know? The audio is a bit weird, but yeah, we're happy with that. It should be HTML only, standalone. Channel 5, so it's loaded the data. Everything's hunky dory. It's really nice, really nice. There's still errors. Clear console. Let's reload the page. The wavelet transform failed. Everything else seemed to work really well. Well, let's call it a success. Let's call it success. We don't have play button. Should be able to add the play button. It corrected. Oh, what goes there? Uncode there. Blah blah blah. Models this. Okay, now we have two versions. So we're having trouble with version control. We'll have a lot of trouble. We will have a lot of trouble. Let's create a copy, and the new index.html. Let's take it from, because this one's Gemini 3 Pro, so we should be better in theory. And we have a winner. The code assist made the better, something better. So let's revert, move to trash it. Okay, this one. Okay, it's showing the frequency spectrum, the raw denoised EEG signal. Can scroll. Yeah, the audio is weird. They're meant to be musical notes. Okay, so I'm also getting the following errors. The musical notes don't sound natural. Originally we had some library that was playing more like piano notes, and there were like 4 of them. So what can you look up the code, the Python code we shared before? Or it should have been in JavaScript. I don't know. In the Flask application, can you just explain what did we lose in terms of functionality by migrating the Flask application into a vanilla JavaScript? We have the index.html selected. I don't know if it lost the, I don't know what the context. Copilot was showing you the context window as well. How much percent is being used. This one doesn't do it. So I don't know exactly if it still has access to the Flask application code, the Python and the JavaScript. Not sure. We'll see. And we should be also adding the play button. Should be an easy one. But yeah, we might we have like bigger fish to fry at the moment. We have more serious problems. Okay, we might try it next time. So yes, we were able to convert the Flask application into vanilla JavaScript, supposedly. Well, front-end only, still using some libraries. What is it using? A wavelet transform and Plotly. So Plotly is fine. It's for plotting the graphs. That's okay. Wavelet transform. Yeah, I don't know if we needed it to begin with. But we lost the new ones in the sound. So that's what's the new one doing. And that's what the old one used to do. Yes, so obviously the transfer from Flask application to vanilla HTML was not complete. Yeah, because we were actually mapping piano notes based on the spectral energy in each band. So that's why I had 4 notes. It's for on a scale matching the energy within the delta, theta, alpha, beta spectrum. But now, obviously, we're not doing it anymore, and we're getting some error messages as well. Wait, is there... The frequency transforms seem to be accurate, so the FFT is working. I think it removed the FFT JavaScript library and just used one vanilla. Wrote one by itself, which is what we like. Because I mean, if it has access to the thing. Wait a sec. Yeah, so the frequency spectrum is correct. Window size, channel selection. So it's loading the data correctly, that's fine. Do auto volume, auto duration. This. Well, it's. I thought to begin with, I thought it's doing the same sounds for everything, but. So it's stretching. Oh, it's one of those HTML thingy that keeps stretching the why it's happening. Something in the CSS, it's messing up. I think maybe there's a conflict between the global CSS we have for the whole website and the CSS specific for this web application. But yeah, we'll have to look at it next time. Yeah, so you can still use the original one. The original Flask application is still deployed, so you can just use that for now. It's working fine. Just want to try to get rid of the backend when it's not actually necessary. So that's what we were trying to do today. It's a mixed success. Everything we do is on BioniChaos.com. Go check out the website. Let us know what you think, and let us know which bots, or if you're a human and you would like to join our streams, you will be more than welcome. Otherwise, let us know which bots you prefer for voice models. What do you use? I'll see you next time. Bye.